I'm very happy to welcome Andreas. Hello. Andreas Günther from our development center, competence center, hydrogen in California right now, right?
Yeah.
So very nice to have you here. Talking about hydrogen, I said it in the beginning, it's kind of a, I would say kind of a hot topic right now. A lot of people talk about it, but in the preparation I found out it's not a very new topic, by the way, on the technology side. So can you tell us a little bit about this?
Yeah, Stefan, first of all, thanks for the invitation and thanks for joining our webinar this afternoon or this morning in the United States. I saw the United States are the most participants. Thanks for joining. Yeah, to answer your question, a fun fact is actually that the first ever built combustion engine actually ran on hydrogen.
Okay.
So, but then we found out it's just cheaper to drill a hole in the ground and get out the cheap oil and energy collected millions of years ago by the sun. So this kind of destroyed all business models around hydrogen, and it's kind of bad. But now then we found out it's not so good to get the carbon dioxide in the atmosphere. We cause global warming, and by finding that out, the hydrogen will come back as an energy carrier produced by renewable energy sources. And now all of us engineers and our customers, everybody need to stick together and do the best what we can to prepare our technology to make hydrogen successful.
Is this also the reason why the oil drilling originally came from the US, that you are located in California, or does it have another reason?
No, the reason actually is that we have a very good experience in past of developing new products by doing this close to the market.
Okay.
And if you look on our planet, for an ecosystem that is already running on hydrogen, you need to go to California. So in California, we have about 16,000 hydrogen cars on the road. Wow. And about 60 stations in operation. And this is quite of a good ecosystem to learn and explore and then expand over the globe.
Okay.
And we are there cooperating with a company called First Element Fuel. The brand name is True Zero, and they are the leader in operating of the refueling stations. And together with them, we get our products in the market. We get field experience very early, and as soon as we bring them to the global market, they are already proven in reliability. And just to give you an example of the relationship, 1 week of testing in California is equivalent to about 6 years of field experience currently here. Okay. Because of the lack of users currently. But they are coming, and then we are prepared.
So it's not only the Californian sun why
No.
you went there. And Bosch as a company, of course, we are very into the field of sustainability. Is this also a reason why Bosch is so let's say active in this field?
Yeah, of course. So as the largest automotive supplier, we feel responsible to contribute to decarbonization of the mobility sector. So every part of our business units have projects to push in that direction. For us, it's very important to be open to all technologies. When I talk to my friends and tell them what I'm doing, some people are arguing, we have battery electric cars, they are way more efficient. Is it really the way to go with hydrogen, or is it just a hype? And the answer for me is always, it's not all about efficiency. We have all the same target. We need to decarbonize the mobility sector. And therefore, we need all technologies. And you see it here in the cycle, depending on the use case, there is not only the efficiency what counts. There is charging time, there is distance, there is utilization, there is how many cars you need in your fleet if you operate a truck fleet. So it's all need to be taken into consideration to see what's going on and what is the best solution. And we believe you need all of them to be successful.
For those of you that find it hard to read the content here, we know that you cannot read it right now. Of course, you will get the slides after the session, and of course the links will be sent so people can read that.
For sure.
So you said it's a mix that is necessary, but it's basically also a huge, I would say, a huge line or a lot of areas where hydrogen can be used. Is there something that you can tell us about this?
Yeah. So especially if you look in the ecosystem, you see that Bosch is contributing over the whole value chain. You see it from the left side, from production, we are building electrolyzers, we are building water purifiers. Then in the middle area, storage distribution, you see that woman filling a truck. So we're making the drives for the compression. And also on the usage side, we are building stationary and mobile equipment around fuel cells, the fuel cell itself, and also around the combustion engine.
So it's kind of a big ecosystem. And I think that's a good time also to get back to our participants. We have prepared another question for you guys. In which part of the hydrogen value chain you are active? Is it, as we see here on the left side, the production side, or on the right side, the usage, if it's the compression or refueling, transport, services? Let's spend some seconds giving you the answer. So almost 100 people in the line right now. So after 20 answers, we see a huge majority not active in this field right now. But those who are, they are mainly into the compression. And I think, yeah, we are happy that we talked about this in preparation. Of course, it's the headline of this web seminar. So we are, of course, focusing this topic. But we also see usage, production. But yeah, majority, I would say, compression, but also a huge majority, at least half of them, are not active in this field right now.
Good chance for us.
So good chances, and also, yeah, good chance for users to get really first-hand insights. So I would say, now we talked about the technology itself, how it evolved. I would say 200 years of sleep, almost, and the contribution of Bosch. So, but now moving a little over to our company, to our subsidiary, Bosch Rexroth.
Yeah. So
what is our main aspect? What is our main interest, and what do we bring?
Yeah. So Bosch Rexroth is within Bosch the business unit responsible for the industry sector. So this is basically where we're located, and here in Lohr, especially in hydraulics, we love pressure.
That's for sure.
And in hydrogen, you need to get it to high pressure. And the question is, why do you need to do it?
Can you have a comparison? So I know that a typical pressure range is 350 bars in hydraulics.
Yeah, so in hydraulics it's about 300, 350 bar. When you go into the hydrogen area, the current standard that's getting to be established, it's more going in the direction of 700 bar.
Also at least
double of it. And of course, it's more challenging regarding the density and the sealing and the temperatures. But in general, it's high pressure, and it's our passion to work in that field. And yeah, why do we need that high pressure? So if you look at the energy density regarding mass on the left side, you see that only nuclear energy is higher. But if you look for the volume, it's very low. It's the same density like styrofoam. So it means even if it's under 700 bar, so that's why we need to compress it very close together, or we need to liquefy it, that we get the energy density needed for the mobility.
That's also I like these pictures too, so they're very clear to relate to. So now we talked about, again, kind of an overview level. I always ask our experts to bring in some application examples, and even if we are quite new in this field, I think you have some.
Yeah. So let me show you a short movie clip. This is a rough overview about refueling applications, beginning from very small volumes. For example, here the forklift filling. Actually, in the US, more than 60,000 forklifts have been changed to fuel cell, and the operators find out that they can decrease the amount of forklifts based on that because of fast charging. Then you saw the car filling, and here also a good application in the future, getting the off-road machineries to hydrogen. And for sure now the way to go to decarbonize mobility is to fill heavy-duty trucks. And there, the goal is to fill it within 10 minutes. And this is the challenge.
Okay. So I just learned from our marketing department, that's the so-called white world. That's a kind of a simplified version. So it really looks quite simple over there. So trucks just moving in, 10 minutes and it's filled. Is it as simple as that in real?
Marketing did a good job and make it very simple.
That's their job.
And let me also try to explain it very simple. Of course, the challenges are in detail. So I always like to compare it to a bicycle pump. Compressor, and sorry to the people that are in the compression area to simplify it too much, but it's good to explain it. It's like a bicycle pump. You have an inlet check valve, you have a discharge check valve, you have pistons with seal, and you have muscle power to move it. And basically the muscle power is where we need hydraulics. Why do we need the hydraulics for that? It's because of the high pressure. So if you fill a bicycle with about 7 bar, and now we are filling it with 700 bar. So that's why hydraulic is perfect for that. And now if you look on the right side, the motion profile. Here you can see what makes the difference. It means if you would like to increase the mass flow, you need to accelerate fast, move fast, decelerate fast, and change fast the direction. And then you can make sure you get the most power out of that air pump. And if you then challenge it with the requirements, you need to make sure that your pump is reliable, efficient, scalable. And just some words about that. Reliable means, of course, a lot of, if you are fast with your pump, you try to move it into the end. But if you crush into the end, you are damaging the pump. So reliability for us means that both our hydraulics are reliable, but also we make sure that we treat the compressor very gentle, that also the compressor is very reliable.
Okay.
So we stop before the end, but we need to make sure, regarding the next point, efficiency, that we not stopping too much far away, because then we have clearance volume and we miss to push it out. And if you look at the pressure curve, the last one is the most important. So we need to go to the end, but not hitting the end. And then we are reliable and efficient. And this is where the controls of the hydraulics are making the difference. And for sure also scalable. So we have from small to big all the same architectures to make sure we can fill small forklifts and fill big trucks with the same architecture. And then we also have additional soft requirements. Those refueling stations are placed in the urban environment, so you need to care about noise, you need to care about space. And a lot of times you don't have maintenance people around it, like in a plant. So you also need to take care about remote condition monitoring.
Looking at this picture, I hope I can ride my e-bike on the weekend. But yeah, so looking at this, it's again, I think nice that you have explained it in a simple way, but you're already relating to the core benefits, what we call connected hydraulics. So when I see scalability, efficiency, I think that's why we are now also in with Rexroth from the field of connected hydraulics.
Yes, that's exactly the point. And in connected hydraulics, we made one huge differentiation to the state-of-the-art hydraulics.
Okay.
And let me explain you the main point.
Let's have a look.
So if you look on the left side, you see how traditional hydraulics work. You have a motor, constant speed, you have a variable pump, making a constant pressure system, and you have a valve that is controlling the motion profile of your hydraulic cylinder. What you do is you control the motion by braking. What we do with connected hydraulics is we put a lot of features into software. We add a frequency converter, a servo drive, and then we can modify the speed of the motor. We can control the pump very accurate, and we get rid of this throttling, and we control the motion only by the gas pedal. And this is increasing the efficiency tremendous. So what we do is to bring it together. We use the strengths, the strengths of and the robustness of hydraulics as a hydrostatic gear. We're using the controllability of software by having a lot of hardware functions put into software building blocks. And we're using the efficiency of electrics, and we put it all together. And this is what we call electrohydraulics, connected hydraulics. And this is making the biggest differences regarding robustness and efficiency.
So I think, and yeah, obviously efficiency is one of the most relevant topics. Because it relates to one of the most relevant topics, the costs from the customer side. So again, coming from an application view, I think you have prepared something. I would really love to see some details on how's the effect on the cost side.
Yeah, so this is, when we are talking about costs, we need to separate between the CAPEX and the OPEX. Of course, the CAPEX on the left side, you see if you go from conventional to connected hydraulics, we are a bit more expensive.
So you mean capital expenses?
Yes, because we have whole electrics included, and it's an additional value add to the system. But you can look at the initial costs. We already save some commissioning efforts just by pre-commission everything, pre-test everything. This gets the field work down. Okay. So for the OEM, they can benefit about faster commissioning. And then the real benefit is the red bar on top of it, which is the efficiency. We talked about valve control to pump control. we save about 70–75% of energy. And here you're making the huge difference. The TCO, total cost of ownership, after 2 years, it's already going down and you benefit from it. And these units are running for tens of years. And this is then saving a lot of money over the years. So the message is we should focus on low operation costs and invest a bit more in CapEx. And then we have a really, really economic system.
But you have concrete numbers with you, I think?
I have. So in California, we have a hydrogen refueling station. It compresses to 700 bar. It's driving a cryopump, 80 kilos an hour. We have a valve control system. We measured the energy. It's about 85 kilowatt. We changed it to a pump control system. We have 23 kilowatt. And actually the energy price is quite high. So users in the refueling market have higher energy prices because they are not in this plant environment where they have big contracts with the energy supplier. So there's the business case for low operation costs is even earlier taking off. And if you read these numbers, 73% energy savings and almost 60,000 a year at 10 hours a day runtime. So this is the way to go.
And there's plenty of room, just thinking about expanding the hours of runtime and also looking at the energy price and the development the last years. I think the direction is also clear. So I would say 2 years, you now have 2 years TCO evaluation, so it could be like it's an ROI already.
Yes.
Even less than 2 years.
Yep.
So why not think about that? So thanks for this. This was kind of a really clear example. So so this is, I would say, this is a good example. This shows you a little bit the opportunity. But now looking at our portfolio, what do we need for that? Is it kind of a bunch of different products that we need? What is the knowledge I need to put these together? Is this something we can support?
Yes. So we would like to make it the user as easy as possible. And they don't need to look in all our portfolio and get everything together.
Okay.
We kind of did some work in make pre-configured products that we are sure fit to the market. So they don't need to care about the drive technology. They can focus on the hydrogen process technology.
So be ready. Now we are talking about products. I saw a lot of engineers coming in. I see not too much on the chat. So fire out your questions. Andreas will be ready for that.
Yes. So let me start with our first product, Cytroforce. So we're beginning with the low power range, small scale, power range of about 10 to 15 kilowatt, force range of about 200 kilonewton, and you see it's a really compact solution. It almost looks like electromechanic drive, but we have the beauty of the hydrostatic gear. So you see a servo motor, you see an actual piston pump inside, you see a volume compensated hydraulic cylinder that allows us to add a bicycle pump on both sides. So basically we're pumping in 2 directions, which allows a continuous flow and increasing the mass flow to it.
And we see here with the small logo on the corner, we had this question in the earlier round. So it's ATEX compatible?
Yes, so the 10 kilowatt version, we already have ATEX certified for the European market, especially. It's a bit higher than NEC 500 for the US. We have more products for NEC 500. In Europe it's quite challenging, but this product fits even that really high regulations of ATEX. And it's like you see the second symbol on the bottom. It's ready to go, just connect it to your converter and then you're ready to go to compress.
I have a question coming in now from Raul. Hi Andreas, thank you for the presentation. Why is hydraulic compression better than mechanical? What are the physics behind? So prepared for physics session.
This is, okay. So first of all,
he will talk about it in 30 minutes, so we should take it short.
Yeah, let's take it short. If you do it electromechanic, you have 2 ways to go. You can make it with a ball screw or planetary gear. This is similar to a hydraulic cylinder. We calculated a bit, but it would work for the small ones. But as soon as you go higher than about 15 kilowatt, it's getting very, very expensive and big. So there, hydraulic has its strengths. The second solution for electromechanic would be a crankshaft. The crankshaft has the disadvantage, it's only working for short stroke. And short stroke has the disadvantage of high load cycles, and the dead volume in comparison to your stroke is very high, so it's not so high efficient. That's why we believe that, and also the results prove it, that hydraulics is really the best drive technology for piston compressors.
Okay, so I hope this answered your question already, Raul, but you will see later on, can also get into contact with Andreas and you can elaborate on this a little more.
Exactly.
We have done already a web seminar on the Cytro4 some year ago, but I think you also prepared a small animation how it will work.
Yeah, let's have a look inside. So this is visualizing how pump control works. This is the first. I will tell you now also a second version how to do it. This is the first one. You have a servo motor, and by change of direction for the axial piston pump, you are driving this hydrostatic gear and moving the hydraulic cylinder back and forth. No throttle in between, highest energy efficiency, combining the robustness of the hydraulics with the controllability and efficiency of the electrics. Coming to our second product. The second product is our Cytro-Core for hydrogen. It's a closed loop system. It has an A4 pump inside, also on servo motor. It has about 75 kilowatt power, and it's able to directly drive this hydraulic cylinder. Has electric drive inside, has the control inside, everything pre-commissioned, and it's fitting to a kind of sweet spot in the market. So a lot of customers we have talked to, this product fitted right out of the box. Let's call it like
and
this.
Talking about box, it looks like a Cytro box, but I understood it's not a typical Cytro box. It's kind of a pimped up one.
Yeah.
It's a little more focused on the needs for this application.
Exactly. So it looks like a Cytro box. We made it in that shell because our customer liked this fridge design because it's so less floor space. But what we did is, it's not for open system like a traditional Cytro box, it's for closed loop. So directly driving a cylinder. So we get rid of this big tank. We only have a small tank, and this allows us to increase the power from 30 to 75 kilowatt and get even more power out of the same install space.
Okay.
And now I explain you the second version, how you can do it with pump control. So you can use an axial piston pump and change the swash plate of the pump. You see it in this animation from positive to negative, and this allows you to keep your motor speed the same. So the first one was you change direction of the cylinder by your direction of the motor. In this case, the motor stays the same direction and you just change it internally of the pump. And this is especially an advantage because we are talking now about bigger motors, about bigger inertias. We don't want to change direction all the time and lose the inertia energy. And this allows us to even increase the energy efficiency. And also regarding the ATEX or hazard area and non-hazard area, you see the split wall in the middle. Typically, the Cytro-Core is in the area where all your control cabinets are. So it's the non-hazard area. And the hydraulic cylinder is in the hazard area together with the light blue hydrogen part. That's why we developed an own cylinder portfolio to meet the hydrogen application. So it's a customizable interface for direct mounting of your compressors. It has special sensors included for making really high accurate end positioning, and it's scalable in stroke length and in force by the diameter. So really cool portfolio. By the way, also special sealings for that application to increase the lifetime at this load profile.
Yeah, and also we had this question, leakage rates are down to the minimum, I understood, also to these sealing connections. If we look back to the animation that you showed, I was a little bit surprised. So if you could go back and show it again. I was missing a little bit the typical hydraulic setup. So it's not a big tank. I don't see too many classic hydraulic appearances here.
Yeah, exactly. So this is what connected hydraulics is. We moved all the control, mechanic hydraulic control parts into software building blocks. And by doing that, the hydraulics gets very simple. Also makes it more robust. And
from the solution side, but you need to know a little more, right?
Exactly. And this is then the issue. So coming from the whole hardware discussion or also to software, what we worked on the last years is to clean up our portfolio and of all the software building blocks we developed and made it more in an app-like design. We call it Hydraulics for You. This is basically a modular software platform a portfolio of all our know-how of how to control hydraulic drives within the last 20 years. We learned it from presses, from injection molding machines, from all that. And also we now learned from hydrogen compression, and we developed an own software building block called Compressor Drive Control. And it's specially made for that, has some features for that to increase efficiency, endpoint control, all that topics.
There are a lot of questions coming in, so if it's okay for you, I will just do a short cut right now. One question is coming from Norman. Can these products be used for compressed natural gas as well?
We had this question also in the other one, right? Yes, this one's yes. So because we're just providing force and speed, so mechanical energy. So depending on what compression head you put on it, you can pump hydrogen, you can pump nitrogen, you can pump LNG, as long as it's in the power range.
That's what was asked for, LNG, yeah.
Yeah, so as long as it's in the power range, we can do that.
Okay, so I hope this answered your question. Then unknown user, what keeps high pressure hydrogen from migrating, leaking into the hydraulic fluid?
Yeah, so we have actually more barriers to it. So the first is, maybe I show the picture of the hydraulic cylinder. So we have, if you would imagine how the cylinder head looks like, you have multiple sealings in it to make sure that the hydraulic is not getting out. So we even have measurement points between the sealings to see when the primary sealing is gone and the pressure increases to the secondary sealing, we can already stop, but we still don't have an external leakage.
Okay.
And then we have a third barrier, which is also a hole to the outside that makes sure that even if the second sealing is gone, we don't contaminate the hydrogen area.
Okay.
So basically it's a mix of multiple sealings in combination with field measurement, and let's make sure that we don't have an issue in contaminating.
And I think also the last question here from Piotr goes a little bit into this direction. How do you ensure the purity of the hydrogen after the compression? Will the cylinder be completely leak-proof? Oil residues on cylinder walls are not acceptable in hydrogen for fuel cells.
Yes. Yeah. So we don't have hydraulic oil in that area where the hydrogen is being compressed. Of course, we don't have influence on how the OEMs build the compression heads, but even though there is not a moving part at the same sealing surface, that thick contamination can happen. So
thank you for your questions so far. We will proceed, but at the end we will have some minutes left, so please go ahead with your questions. So you talked about H4U, hydraulics for you. I think this is also one of the key topics on the Hanover Fair next week.
Yep.
And I think you have brought another, I would say, digital topic with you.
Oh yeah. So the Hydraulic for You is basically the software platform on automation level. But when we have all this data already digital, then we need to make sure that we also bring it in the cloud, enable you to have a digital service. And I mentioned it at the beginning, that we need to make sure that all those stations are decentral over the country, that we don't run to fail, like you see on the left side. We need to go a bit higher and make sure we make condition-based maintenance. We need to make sure that you have a user-friendly dashboard that shows you what's going on. So if a service guy needs to go on field, he has the right tools and he has the right spare parts with him, that you can make an efficient maintenance operation.
Okay, so again, there are some informations here. We have done web seminars on both topics already. H4U also is something you can visit on. Also, I think there was a question already. See it. Of course, you will be there on Hanover, and I also saw on social media there was an interesting post I saw some days ago from Bosch Rexroth concerning a new product. First, they thought it kind of a new Cytro product, but it's a little bit differently spelled. It's cryo pump, and it sounds like it's kind of a deep temperature pump solution.
Yes, it is. So that up to now we talked about only electrohydraulic drives to drive compressors and also cryo pumps. But within the last year we also worked on developing an own cryo pump, because we found out that there is not a big enough cryo pump currently on the market that fulfills the market requirements. And also we saw a lot of similarities to what we do in our traditional business. That's why we said we have a huge potential to develop an own cryo pump. Some words about where the cryo pump is needed. So it's depending on how you supply your refueling station. If it's supplied by gaseous hydrogen, you need a compressor, gas you compress. but if it's liquid, it's cooled down to 20 Kelvin. That's why cryo. Then you're pumping it. So basically a cryo pump gets supplied by liquid hydrogen, and then it compresses it or pumps it to 700 bar hydrogen. At the end, it's all the same. It's 700 bar to fill a vehicle. And what means new generation of cryopumps? We had this question before. For us, it's a pump that is big enough to move from storage bank to direct fill. Some words about that. The current station layout having usually smaller pumps that are filling a cascade of different storage banks. And then you have a valve that then supplies out of the storage banks to, for example, a truck. And what we would like to do is we would like to provide direct fill opportunities. So we have a pump that is big enough, and we have a pump that is controllable, that you directly can fill a heavy-duty truck with 700 bar within 10 minutes. So you can get rid of your storage banks, you can make your station more simple, smaller, and you can reduce a lot of capex based on that.
So, and now we see here already a glimpse of the product. It's
so
still a carpet on top of it?
Yes, so unfortunately I can't lift it today.
Okay.
So feel free to join our Hannover Fair next week on Monday. We will lift the carpet, and just can tell you it's an amazing product, and I'm really happy to share it to the public.
I think we will talk a little bit of the fair in a second. So I think just to summarize a little bit what we have talked about, can you just do a very short summary?
Yeah, so in general I can say the connected hydraulics, so using the strengths, the controllability and the efficiency of connected hydraulics, we develop products from the Hydroforce that can fill forklifts until really heavy-duty filling with a cryo pump. So the whole range, this is our goal, and not only hardware products, also make sure that we have the right software and the right digital services to it to provide you the right drive solution for your refueling application. We focused on what we learned from our customer, that reliability, efficiency and scalability is very important. That's why we said we need to make sure that every software and every hardware is always linked to the three main requirements. And now we would like to enable you to make your refueling station more economic. And we know that like you mentioned at the beginning, we lost 200 years of development because we had cheap oil. So now it's up to the engineers from our customers and our own engineers to work together to speed up development. And that's why we believe we need to work in more a community approach, in a partnership, instead of just a supplier-customer relationship, to bring the best people to the table and make hydrogen successful.
So he's of course one of them. So thank you already for presenting this. And this is a clear call to you. I think go back to us if you have questions, if you have ideas. We saw 50% are not in the field yet. So I think there's a lot of potential over there, as you said. But I think I understood you already have collaborations going on.
Yes, we
have. You mentioned one company in the beginning.
Yeah, so we have a bunch of companies we have worked with. So each of our product was developed with a pilot customer to make sure it fits to the market. And over the months by months, we get additional pilot customers, and we now have a huge summary of partners we are working with, and it's increasing on a daily basis. And hopefully also when we are now going to the Hannover Fair, it's a way bigger opportunity to let this community grow.
Or even today, maybe somebody's already in the line to get into contact with you. Just to finalize, I would say, I saw the question twice already. So it looks like you created an urgency of information. So of course this presentation will be shared with you due to your registration, but also there's a lot more on the web. So I think you can show, we have this website prepared with information. Hydrogen at Bosch Rexroth is a keyword here. We have videos. If you're a partner, there are press information, press releases that you can use for your customers. And of course, the most relevant aspect you see in the middle, Andreas is also, of course, on social media, on LinkedIn, you can get into contact with him. And you saw already starting this answer, we had a session in the morning when he really started explaining things. You can listen to him for long. So go to him, go to the Hannover Fair if you can. I'm not sure if it's in your travel plans, but just can tease a little bit maybe. I think you have prepared also
Yeah.
information. What will be really your main thing to show?
Yeah, so basically the topic of the Hannover Fair is energizing a sustainable industry, and it fits perfect. We are not only operating our own plants in a sustainable way, we have sustainable products, very efficient products, and also the sustainability market with hydrogen. At the fair, we are publishing our hydrogen story. All the products I showed you virtual, you can touch, you can really explore them. And we have a lot of our R&D guys there you can get in contact with, because we think the best solution is always coming out if you connect the right R&D guys. And for the people in the US, in 2 weeks there is the OTC. So we also have a booth at the OTC. And by end of June, there is the big hydrogen conference in Houston. So we also have a booth there. So you don't need to invest in the very expensive ticket to come here to Hannover. So we are also present there and warmly welcome. I will also be not at the OTC, but one of our colleagues is there. But at the Houston show for hydrogen, I will be there.
Perfect.
And hopefully to get in discussion with you.
So thank you already that you've been here. I think it's, I know that it's kind of a long travel, and but yeah, you combine it now with the Hannover Fair. But use as much time as possible in this development. I think it's a perfect timing, and I think it's filling our main topic also of efficiency and sustainability. So now looking at the questions, we have 5 minutes left as proposed. The first open question: for hydrogen compression, standard fluid or any special fluid is used? So are you using typical mineral oil, or are you have
HLP, HLP 46, HLP 32, typical mineral oil in that application?
Okay. Then I think you mentioned it already, but from the hydrogen side, what is the maximum pressure?
Hydrogen side, it's going usually up to 900 bar. In the vehicle, it's 700 bar.
Yeah,
but a lot of products are specified to 900 to have a room for pressure drop in the line.
Then question on the CytoConnect topic: the digital services, can they be customized to different hydrogen products?
Yes, they can. So we have pre-commissioned to each of our products, but we can also customize them. We call it engineer to order, so there is potential to do it for that.
Then there's just a kind of a nice feedback from Grégoire. Looking forward hearing you more about this next week. So you will have definitely one guest in Hannover.
We have one appointment.
From France, it looks like. Then Steve, are you partnering with Bosch to show the complete ecosphere we have as a company? I think
yes.
He means...
Yes, so even at our booth. So this is one thing that brings all of our Bosch entities together, because hydrogen is all over. It's from heating systems for houses, for everything inside. So, and also at the booth we have what we call the e-distance truck. So it's kind of a shell of a tractor with our fuel cell inside, with all of our components inside. So it's really interesting. We look at the whole ecosystem. Currently we find out the usage and the production is quite good. Currently the bottleneck is the infrastructure, and this is where Rexroth is working on.
Perfect. And then do these systems meet ATEX requirements? We talked about it partially at least.
Yeah, so the cylinder and everything in touch with your compression head or with the pump for sure. If it's the electro-hydraulic drive system like the Cytocore, it's currently not. We're currently working on preparing it for NEC 500 for the US. For ATEX, it's a longer way to go. Currently we say for ATEX the Cytocore is placed in a non-hazard area, which typically works because you have control cabinets and other stuff anyway. And we proved it by long distance hosing and piping, and we still get good end position accuracy. So no issue at that.
Wow, this was really great, Andreas. And I think this was the first web seminar where we had that much questions. So I think you will have a lot of time discussing next week. There will be a lot of interest, I can anticipate. So get a lot of rest until the weekend. I think it will be really, really interesting. So again, thank you for having you here. Also, thank you for participating today. I just want to highlight that we have another web seminar coming up, kind of the same field, on energy efficiency. So it's the 6th of June. So be sure to be there if we do not see you on the Hannover Fair this year. And before you leave, please leave us your feedback. We always have 2 feedback questions for you at the end, just to see if we fulfilled your expectations. Again, thanks to you.
Yeah, thanks for the invitation.
Have a good time in Hannover, and see you next time. Bye-bye.
See you.